Okay, so we are working with composite functions here. Here I have a couple of examples of two functions. For example, h of a equals 4a plus 5, g of a equals a squared minus 2, and our task is to find h composite g of 3, or in other words, h of g of 3. Now, the best way to do this problem is to start from the inside. So perhaps we should do g of 3 first. Now, g of 3 consists of evaluating g when a equals 3. So here we got a squared minus 2. So we're going to go 3 squared minus 2, which gives us 9 squared minus 2. Oops, not 9 squared. We meant to say 3 squared, which is 9 minus 2, or 7. Then we have to compute h of 7, because this is what g of 3 was. So then for that we need to come up to the other function. That means that h of 7 is really 4 times 7 plus 5. And of course, 4 times 7 is 28. 28, and then we add 5 more. That gives us 33. 33. All right, so that's one example. Now, sometimes we can have something like g of x equals x minus 3, and they want us to find g composite g of, say, negative 5. Well, this looks a little weird because we have to insert g inside of itself. So we're going to do g of negative 5. So we have to evaluate g first at negative 5, which gives us negative 5 take away 3, which then becomes negative 8. And then we have to evaluate g again, but this time at negative 8. So we're going to go g of negative 8 becomes negative 8, subtract 3. And of course, minus 8 minus 3 would be minus 11, negative 11. Put that in here. Okay, so let's try something like this. For example, let's say I have something a little more complicated, because they can get really complicated pretty fast. So let's do f of n equals n squared plus 3n. And our second function, let's call it g of n equals 3n plus 2. 3n plus 2. And they want us to do f composite g like this of n over 2. This can be rewritten as f of g of n over 2 like this, which means we have to compute g of n over 2 first. So let's do that first. So we're going to go to g of n over 2, then becomes 3 times n over 2 plus 2. If we rearrange it a little bit, this would be 3 halves n plus 2. And then we have to do f of 3 over 2 n plus 2 into the first function. So then we're going to get 3 over 2n plus 2 squared, add another 3 times 3 over 2n plus 2. And of course, we have to expand this a little bit. Let me make some space for that. So if you notice right here, these two have something in common. So we can actually simplify before we multiply. Rather than squaring this, why don't we try a little factoring? So we're going to factor out a 3 over 2n plus 2 from both of these. They have something in common. When I do that, I get 3 over 2n plus 2. This goes away, so I get a plus 3 here. And as you can see, I can simplify this guy to be 3/2 n plus 5. And then I have another 3/2 n plus 2. Now this is a lot easier to multiply than squaring all that stuff. So we're going to go 3/2 times 3/2 is 9/4 n squared, and then 3/2 of this will become 15 halves n plus 3n, because the 2's cancel out, plus 3n, and then 2 times 5 will be 10. And this can simplify a little bit, so let's put this over 1 to find the common denominator. So this would be 9 over 4 n squared plus 15 over 2n, and this becomes 6 over 2n plus 10, so I can add these guys. So 9/4 n squared plus 15 and 6 becomes 21. 21 over 2n plus the 10 over here. As you can see, this one is quite long. As they do in Algebra 2, they go pretty fast, they get complicated. Let's try one more. So here we have a composite pair. We're going to have h of x equals 4x minus 1. And the other function, let's try a different color, they're getting monotonous here. G of x is given as 4x minus 5. And we are defined, let's do it in another color just for variety. Find h composite g of -10. Okay, so in this case, we can evaluate g of -10 first. Let me rewrite this so it's more. This becomes h of g of -10. So then we do g of -10 first. So g of -10 actually becomes 4 times -10. Subtract 5. And let me change the thickness of this pencil a little bit. So 4 times -10 becomes -40. Minus 5, which is of course -45. So then we have to continue with h of -45 into here, becomes 4 times -45, subtract 1, and so -4 times 45 in 45 times 4 is actually, well, this is a negative here, so it's -180. So we get -180, subtract 1, And of course, this gives us minus 181. So these are composite functions. They can be a bit messy, but if you take your time and go slow, it shouldn't be too much of a problem. Oh, well, there might be, but it'll be fun.